You are going to learn hygrometry. Today I am covering the lesson hygrometry as three parts. First, saturated vapor, dynamic equilibrium, and how the pressure is varying with the volume for little amount of liquid. When you learn about the hygrometry, at the first you have to know the saturated vapor. What is saturated vapor? When a liquid is at dynamic equilibrium, its vapor is called saturated vapor. Then we have to know dynamic equilibrium, right? See here, this is a container with a liquid. This has been closed. That means it's a closed system. Now you know this is the liquid phase and this is the vapor phase. Have a think, the temperature which affected to this system is constant, and also here the volume is also constant because it has been closed. Now these molecules of the liquid phase are moving to vapor phase, and also molecules present in the vapor phase are moving into the liquid phase. With the time, these rates, what rates? Rates of molecules from liquid to vapor phase and rate of molecules from vapor phase to liquid phase. Those rates are being equal with the time. That means the number of molecules leave is equal to number of molecules arrive for both phases. So now we can say this system is at dynamic equilibrium. Okay, let's move on to third part. Let's see here, there is little amount of water inside this. This piston can be moved up and down. Have a think, the temperature is constant. Now this piston is moving up. Now the volume is increasing inside this. Can you guess what is happening now inside here? I am asking about the number of molecules in the vapor phase and the pressure of vapor phase. After that, suggest the way this graph can be plotted. Volume is increasing, and then what happens to the pressure inside this? Now see this. It is important fact. Here, when increase the volume, the number of molecules which can be inserted into vapor phase is also increasing. Then what happen? Now break this, its dynamic equilibrium, and rate of molecule from liquid phase to vapor phase is increasing. The number of molecules inside vapor phase is increasing. But until the liquid is available, the system can be recovered. That means system can reach new equilibrium position and keep its saturated vapor. Because temperature is constant, until the system is saturated, the pressure does not change. Until there is at least drop of liquid. So this graph can be plotted up to evaporation of last liquid drop when increasing the volume. So after that, how this graph be like? Furthermore, the piston is moving up, then volume is increasing and number of molecules from the liquid phase to the vapor phase is increasing, and finally liquid is over. So the vapor phase cannot saturated after this point. Now it behave like unsaturated vapor. Then we can say it is mostly like a behavior of gas. Assuming this unsaturated water vapor is behaving like ideal gas, then we can say it obey Boyle's law. Then the pressure is inversely proportional to the volume. Then this graph is be like. I suppose you may understand all the things up to this point. So I am going to wind up for this video. Let's meet up new with the next section of hygrometry.